Okay, geometry group, we are in our last section of chapter 12, circles in the coordinate plane. Fun, 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 fun. How much fun can you have? Pause, come back and check your work on this warm-up. And for number 1, you should have 9.8. Number 2, 5. 3, 7.1. And this should have been a real breeze. The y-intercept was at -14. So we have -1, -15, 1, -13, and 2, -12. So today we're going to write equations and graph circles in the coordinate plane. Write equations for circles and graph them. We'll use the equation and graph of a circle to solve problems. So here we have the equation of a circle is based on what you just practiced, the distance formula, and the fact that all points on a circle are equidistant from the center, which we call the center. So we can see that if the center is called HK, that any point on the circle would be a radius away, right, from HK. And that is the basis for the circle formula. The equation of a circle with a center HK is the difference of any point xy, right? The difference of x minus h squared plus the difference y minus k squared, which gives us the radius squared, okay? So let's write the equation of a circle, J, with center J at 2, 2, and radius 4. So we start with that equation, right? There it is, gotta have it. And now we're simply gonna substitute the center, HK, in this case they're both 2, right? And we're gonna put the radius 4 substitution, right? Now we're just gonna simplify this and we'll have an equation. What is 4 squared? Yep, 4 squared is 16. So here is the equation of our circle. X minus 2 squared plus y minus 2 squared equals 16. Let's do it again. Write the equation of the circle K that passes through J, point J, 6, 4, and has a center of K at 1, -8. Now this is different because what don't we have? No radius. We've got to find the radius, right? But what do we have? We have a point on the circle, right? And the center. We begin with our circle formula, right? And this time we substitute the known point 6, 4 for xy, and we substitute the center 1 and -8 for the center, HK, right? And because we want r, we'll take the square root of both sides. Okay, so pause, simplify, come back, check. Very good, you should have 5 squared plus 12 squared. 25 plus 144 is square root of 149, which is 13. Okay. Now that we have the radius, we can substitute that into our circle equation along with the center, 1, -8, to get our formula, right? So there we go, we substitute 13 squared, we go right back to 169, don't we? And there is the equation for the circle. So the next question will be, once you have an equation, how do you graph? Well, what's the most basic method of graphing any equation in algebra? Yeah, you can make a table. I've told you that a million times, right? Make a table, get some points, graph them. The other thing we could do is identify the center of a circle and use the radius to find some other key points and draw the circle that way. So let's start by using a table. If we have this equation, x squared plus y squared equals 16, we could just choose some values for x, let's say, and find their partner, their y value when we input that x, right? Now, this equation looks like our circle equation, but 16 then is not our radius, it is our radius squared, right? So the radius would actually be what? 4, right? So we might choose values that are between positive and -4 for the inputs, right? Imagine x is 0. Y would definitely be 4 or -4, right? And we're not going to have a negative, actually we can put a negative, what am I saying? because of the squared term, we wipe out our negatives, don't we? So here's an example of inputs from anywhere from -4 to +4. We couldn't use a -5, I guess I should say, right? Or a +5. That would be interesting. Anyway, so we have some ordered pairs. We can plot them and connect them to make a circle. And there you go, right? Notice that when x is 0, y is 4, 4 squared is 16, right? Notice that when y is 0, x is 4. Those are really key points to me. Okay, let's try graphing this. In this case, the equation gives us what? What point do we see right away? Hopefully you're saying center point, right? And the center here is 3, -4, right? And then what would the radius be? If 9 is r squared, the radius is 3. So in this case, we could just plot that point, that center point of 3, -4, and use our radius to find some other key points, right? And so that's what is done in this example. So the center is plot, and then the radius is used to find other points. And here it is for you. Here it is, the radius of 3. Easy to find this point of 3, -1. Also, this point of -4, 0, right? Also this point out here of 6 and -4, and so on. And we connect, and we know it's supposed to look like a circle, right? Okay, here's an interesting application, radio application. An amateur radio operator wants to build a radio antenna near his home without using his house as a bracing point. Maybe you've seen antennas like this where there are cables that are bracing a high pole to the ground, right? He uses 3 poles to brace the antenna. The poles are to be inserted in the ground at 3 points, equidistant from the antenna, which is located, these poles are located at these 3 points. 4, 4 is pole J, -3, -1 is pole K, and 2, -8 is pole L. So what are the coordinates of the base of the antenna? So the key point here is that each of these poles are equidistant from the antenna. So it's somewhere equidistant from these 3 points. So what could we draw using these 3 points to help us find? And yeah, we could draw a circle, right? You can imagine a circle, and there's some point in here that is equidistant from each of these 3 points, right? If you weren't given a picture of this, the first thing you'd want to do is plot the points, right? And then connect them, and you can see that a triangle has formed. Next, you would want to find a point that is equidistant from the 3 points by constructing the perpendicular bisectors of 2 sides of triangle JKL, right? Perpendicular bisectors, okay? And the perpendicular bisectors of the sides of that triangle intersect at a point that is equidistant from JK and L. So here we have it. Here we have the bisectors. Perpendicular here, and intersecting at this point here, which ends up being the center of a circle that could be constructed using 3 vertices of that triangle, right? And it's at 3, -2. So P is the center of a circle that passes through, and since it is the center of a circle that has those 3 points on the circle, they are all equidistant from point P. So the base of the antenna would be at the center of that circle. A couple of questions for you for this lesson. Give it a try, come back and check your work. Number 1, your equation should be. Number 2 was like the second sample we did today. You have to substitute the known point and the center point and find R, and then rewrite the equation, right? And when you do, you get that. Very good. And pause and graph these carefully. Come back and check your work. This one is given, radius of 2, center at 0, 0, right? And here we have a center at 2, negative 4, with a radius of 4, plus or minus 4. There you go. Very nice. And so you're on your way. Have a good time. Good luck.